Hey everyone, I want to try something a little bit different than what I usually do. Usually I write blog posts about programming, and there was one article in particular I wrote a while ago called Introduction to Functional Programming. I used a list of numbers, adding them up to compare and contrast imperative and functional styles of programming, but there's also a great concept there about exploring map, filter, and reduce that I feel like I just didn't explain good enough. In this video, we'll explore this further, so let's get over to the computer and get started. Now that we're on the computer, let's take a look at maybe how we're generally taught how to add a list of numbers. So up here we have our list with 1, 2, 3, 4. We have a holder of the sum. Here we'll start with 0. And then we'll loop through the list, adding the current sum to the list of items, the item we're currently on. And then just for fun, we print it out at the end. So the addition of 1, 2, 3, 4 is, of course, 10. To convert what we have to a functional way of programming, let's try to break down kind of the operations of what's going on here when we sum a list of numbers. So we start with some value, 0, which is our starting value, and then we're going to add the rest of the list to it. And we're going to do this by pulling each value out and adding it to the accumulation of what we currently have. So if we do this, let's pull out 1 for our first iteration. And then we add the 2 together. So this becomes 1, and then we have the rest of the list to continue on to. We then grab 2, pull it out of the array, and add it to our current summation. This becomes 3. We pull out our 3 value, sum these two together, it becomes 6. And finally we pull out 4. Sum the two together, we get 10. And we have no more items in list. We call this summed up, and we're done. While adding these numbers, there's basically two functions going on. We're adding two numbers together, and we're also looping through the array itself. So let's write those two functions. We'll start with the easiest one, add. We'll take two numbers named A and B, great naming, and we'll just add them together. Done. Now let's write a loop function. So function loop. We're going to need a few things. We'll need the list itself, like a normal for loop, and we'll also need the index of what we're working on. So let's pass in the list, and we'll give it an index too. And just use default syntax to make it easier to use, we'll give the base case, which is 0. Now, let's start with what happens when we reach the end of the list. So if index is greater than list.length minus 1, that's it, we're at the end of the list, so we'll return for now. If not, let's continue going through the list each item at a time. So we'll call loop again, passing our list, and index plus 1. So this is a recursive function calling itself, but each time is incrementing the list every time loop is being called until we reach the end of the list where it finally returns and gets out of the recursive function. Now this is great, but we aren't really doing anything so far. Remember how at first we started with 0 plus our array, and then we kept pulling out numbers. So we added 1 and added it to the sum, got rid of that, pulled out 2, and then this would be our sum, or generally called an accumulator. So let's actually change our loop to keep track of this accumulator as we keep going through. So we'll just call it a Q for short, because accumulator is kind of a long word. And then when we're done with our looping through the array, we're just going to return that accumulator, because that's everything that's over here that would already be summed up. So hopefully that's our added list. And then what is that accumulator? Well, for now we'll make a variable called result where we just add the numbers together. So we'll add what our current sum is with the current index of the list. So this would be 1, 2, 3, 4 as it loops through. The accumulator would be the sum function, or the sum variable. And then to pass it down to the additional recursive functions, we'll just pass down result. So each time it's getting the added numbers and the indexes are incrementing. So now, if we were to call loop on our list, starting at 0, we can leave out index 0 because we have the default here. This would essentially give us the same value of 10. Right now, this loop function isn't very pure. This add function just comes out of nowhere. Let's add another argument where we pass in a function, which will essentially be our add. So we'll call it funct, just to be short, and we'll switch this with funct. So funct is just some function that takes an accumulation and another item. Let's update our loop. So the funct will be add. We can just use it directly because it's a function, and essentially we come up with the same thing. We loop through our list, adding it, starting at a 0 accumulation, and we get 10 at the end. Now bear with me for now. We're going to do something a little bit crazy. We're going to change this loop name, and we're just going to call it reduce. Let's also update these. And so nothing changed. We just changed the naming of the function we had of loop to reduce. But essentially this is what reduce is doing behind the scenes. When you call .reduce on an array in JavaScript, it's basically looping through some array and then squashing it together into one accumulation and returning that result. So even though we have add here, we could essentially add another function. And so as you remember, we have two arguments, the current accumulation and the current item we're on in that list. And we'll just do great naming a plus b. And essentially we could also do return a minus b. And this would start subtracting these numbers from a starting number, which in our case, we're going to make 0. And it will just work its way down. So in the end, this would just be negative 10. Now something that's cool is now that we have a reduce function, we can essentially build off other functions like map and reduce. Let's start off by building map just to show how we might use this. So as a refresher, let's look how a map works. Let's say we'll start with some empty function and we want to loop through a list, luckily this list, and we want to change each value, maybe update it by adding 1 to it. So what this looks like in a functional way is you start out with an empty list and we're going to add some function to an item to the original list. So let's say 1, 2, 3, 4. So we're going to do kind of the same functionality, but adding it back to the array. So we'll pull out a 1, apply our function to it, and then once that's done, we'll stick it into the sum array. Once that's done, we'll grab the 2 out of the original array, put in the function, throw it in the summation array, and then move on. We'll take a 3, do the same functionality, put it in our little machine function, pump out a 4, and then pull out the 4 finally, run a function against it, and we'll pump out 5. And in this case, we're assuming function is our original add function where we add 1 to each item. So let's write that using our existing reduce function. We'll make a function called map, and we're going to be working on the list that we pass in, and we're just going to need some function, something we're going to call against this list. This will end up being this result function. Now we're going to do something a little bit weird. We're going to modify the function being passed in just to make things easier. So we'll just call this mapper. And remember, this is going to take the accumulation and the current item we're working on. So we'll say accumulation and item. Now let's skip ahead a little bit and do the return where we actually call reduce. This might make things a little bit easier to understand. So return reduce, where we pass in our list. We're going to pass in our mapper instead of the function. And then we're going to start with an empty array. Now remember, this empty array is going to be this left side that kind of holds our results. So that's going to become this accumulation here as we loop through the array. So for each item, we're going to want to apply some function to it and then return it as part of the summation array. Now let's do that. So we're going to have our result is going to be some function we call on the item itself. And then we'll return our accumulation, which is an array at this point. And we're just going to concat that result to it. So it's going to apply the function and then continually add the results until we reach the end of the array. And in a sense, this is basically does what we want. So if we call map on our list and we pass an add, let's actually change this because we can't pass it in right away. So we'll do function, we'll take some item and we're going to return add. So 1 an item. So this is going to add 1 to every item in the array. So at the end, calling this, we would get an array of 2, 3, 4, and 5. Let's look at the final function filter and let's check out what this does. So we're going to start the same. We have a summation array and we're going to apply the same maybe function to it, but this time this will return a Boolean, true or false. And then we're going to apply it to our original list. So what this does is it checks whatever item we pass into it, and with our check, if we return true, it adds it to our summation array. If it's false, it just discards it, doesn't add it to it. So let's walk through kind of an example. So let's say we pull out 1 and we're looking for items greater than 2. So we put 1 in there. Is it greater than 2? No. It just chucks it out. It's done with it. Let's try pulling out the next item, 2. Is this greater than 2? Well, it's equal, but it's not greater, so we throw it away. Next, we have 3. We put in our function. Oh, it is greater than 2. Let's add it to our list. And then finally, we grab 4, throw it through our function. Yep, checks out. We add it to the list, and we're done. And our original array is done, so we're complete with this operation. Now let's write a filter function. So function filter, it's going to be the same as map. It takes a list and some function. And we're going to do kind of the same concept. We're going to create an inner function, call it filterer, because why not, which has an accumulation in the item, just like before. And then we'll do kind of the same operation. We'll return a reduce with our list, this time using our filterer, and then starting with an empty array. This will be our summation array from before up here. So the same operation, what we're going to do is check if our function returns true. Item. So if it's true, we're going to enter this body. And let's skip that for now. If it's not true, we're just going to return the array we already have, so the accumulation. So the else path is basically done. Now within the if, what we're going to do is return the accumulation with the item added to it, just kind of like our map function. And this should basically do it. So we call filter on our list, and we create a new function. We'll call it item. And then we'll say if item is greater than 2, return true, else we're going to return false. And this would give us the same output as before. So we would see in the end 3 and 4. So as we've seen, map filter and reduce are pretty useful and have some interesting concepts behind them. So hopefully this helped, and I'll see you guys next time.